Hello everyone, and welcome to this webinar session where we try to unpack the conundrum of reducing energy and CO2 whilst maintaining good lighting conditions for learners of all ages. My name is Mark Mattimo. I'm the Head of Application for Education at Thorn. And joining me today is Ian McRae of Ian McRae Limited. Now, for some of you, Ian may not need so much of an introduction, but for those who have not come across Ian just yet, Ian has been in the lighting industry for what, 30 years now?
A little bit more,
yeah. A little bit more, and specializes in lighting design, consultancy, training, and thought leadership, and has previously held roles such as the president of the Society of Light and Lighting. Okay, so let me set the scene for today's discussion. Currently, we live in the post-COVID world, slightly unstable geopolitical situation. We have rising costs of energy and inflation. We're starting to see impacts of this in the new build construction market, a bit of a slowdown, people turning towards refurbishment in a bid to try and reduce some of these spiraling costs. So with that in mind, what would be the first sorts of things that we would consider within an education facility, given the current climate?
Controversially, daylight. Controversially, because I'm talking to a lighting manufacturer, and you don't sell daylight, but we start with daylight. A lot of old buildings have really good daylight access. You know, not the stuff that was built perhaps in the 80s and 90s, but before that, the 60s and 70s, and even before that, good daylight, high windows, lots of daylight. Why is it good? Synchronizes our circadian rhythms. You know, it's good for health and well-being. Really great research. Strangely, you know, if you go back to 2003, it was out of America, 21,000 students in California. Daylight in the classroom led to increases of better maths, 20%. Increase in maths attainment, 26% in reading. Now that was a bit debated. Come back into that discussion, and the numbers still come out around 26% improvement. If you look out at Bangladesh, Bangladesh is special, partly because it's outside of Europe, and we don't often talk about what's outside of Europe, but they have classrooms with windows on both sides. So their corridor space generally is open air. And they looked at classrooms with windows on both sides compared to classrooms with windows only on one side, and they saw somewhere between a 5 and 14% increase in attainment by the students, in good behavior by the students, attentiveness by the students. So there's really good evidence that daylight absolutely is what we need in classrooms. And the UK government, of course, have put that into their design protocols, if you like. But okay, we're talking to people who want to know about artificial lighting and how do you sell that? Well, if you've got good daylight, you don't need the artificial lighting on.
Yeah.
You still need the artificial lighting because in the evening, when you go into adult education or a winter's evening, 4 o'clock or something like that, when the teacher's still doing some marking, you need the artificial lighting. And as we come into an era of high energy costs and rising inflation, you need to keep those energy costs as low as possible. So you're going to have to start putting in things like controls. Yeah. Just energy efficient LEDs is not enough anymore. Controlling the artificial lighting has to be kind of the second step. Got daylight, use that to impact the artificial lighting.
So lighting where you need it, when you need it, at the right times of day, for the right task also being taken on within the room as well. So.
Yeah, well, we can talk about standards, but if you think about the energy reduction, you know, if you're getting 3,000 lux, top end, 3,000 lux on a desk, you don't need any artificial light.
Absolutely not.
You know, the eye's going to cope with that because we're very good at coping with not necessarily looking at the sun, but, you know, direct daylight coming into a space. Come to 8 o'clock in the evening when I'm in there learning French, you know, on an evening class, there is no daylight. So personally, I need like 500 lux or more because my eyesight's pretty poor in older age. And so you need that artificial light, and it needs to be good quality. So the focus has to be, I think, daylight first, artificial lighting second.
Yeah.
Great quality artificial lighting, and we can talk about that, and then controlling that artificial lighting so you keep the energy costs down.
And by doing that, you're reducing the energy by using the light when you need it. And there's an adverse reaction to that, or converse reaction is you're reducing your CO2 usage anyway.
Yeah, and also if you talk about some of the quality aspects of lighting, you know, you don't just have to dim things now. What if we actually put in lighting that's healthy for students because it follows what's happening outside, or it mimics what's happening outside. It works with our circadian system and all the other hormones in our body that are being controlled by light. And controls and LEDs now give us that chance. We're in an era where you can carry, a computer around in your pocket. So why can't we have light and controls that works for students in spaces still at a reasonable cost? I'm not talking dirt cheap, but we have to expect that quality lighting comes at a cost.
I think that's the point, isn't it? Because I think cost is a big element, especially in a sort of world where there's inflation and people are trying to reduce costs. So almost the converse to that is trying to spend more to save more is a bit of a conundrum in itself. So what do we sort of look for in lighting systems and control systems to actually add that value back into, maybe the upfront expenditure?
I think if you talk about the qualities of light, controls need to make sure things like flicker is not in the space.
Yeah.
And we can talk about special educational needs children who are very susceptible to flicker, but most of us, about 10% of the male population are susceptible to flicker in our peripheral vision. Sorry, ladies, no, it doesn't really apply in the same way to you. But that's not a bad thing in this case. Being distracted by flicker is a bad thing. It's the controls. It's the control gear that powers the LED or the fluorescent, if you've still got fluorescent, that is causing that problem. So if you go for dirt cheap, you're going to get, and I came across one the other day, which was a 100 hertz ripple. So it's the mains frequency coming through the lighting. And the gear was so cheap, the noise on top of that meant that my flicker meter detected really good flicker. It was up in the 1800 hertz or something. It looked fantastic. But when you looked at it, this ripple was really strong. When you sat in front of the light, you could detect it was flickering on and off. So, controls have to save energy. They have to give us health benefits. They have to control, limit the health negatives that we can talk about in more detail.
I guess just to add on to that point, it's about using reputable companies for the control gear, being able to ask the question of not just the data sheet that a lighting manufacturer will put in front of you, but actually the data sheet for the driver or control gear itself. That will also give you a lot more detail as to what is actually going on.
Yeah, I think use suppliers, brands, whatever you know and trust, and you build out that relationship because you'll have projects that work with them, and you'll know their stuff stands up in court, as it were. If you're just going for cheap, and I know there are schools managers, facilities managers who are basically teachers in schools trying to buy lighting to improve their lighting to save energy, and their value judgment is, well, I can buy a flat panel luminaire for less than 20 quid.
But how is the lifetime of that?
Well, I talked to one of them. I did a previous webinar where we were talking about schools lighting, and this poor guy was going out and buying for 20 quid and then saying they last 6 months. What do I do? Well, you have to change your mindset away from its minimum cost to what makes good value. Absolutely. Is it quality of light? Is it color of light? Is it energy efficiency? Is it all of those things? Do I have controls with it? Do I have controls built in, or do I, have something that's tacked on because my building is a little bit older? How do I put lighting into a refurbishment, for instance, with controls and emergency lighting that gives me a usable space compared to a brand new build, which of course you get the perfect classroom in theory on day one, with the lighting in the best place and the controls in the best place and all that sort of stuff. So there's value judgments to be made about good quality lighting that start with accepting we have to use this daylight and we have to respond to that daylight.
And you mentioned it a minute ago as well, was sort of the lighting for special needs, and with introducing artificial lighting into an educational establishment, whether it's for special needs or not, it's all about the users of the space providing the right conditions for them to be able to learn, to concentrate, to understand what it is they're being told. So I was really interested to know a little bit more about the sort of special needs lighting. What sort of things do we need to consider, and what things do start to crop up?
Yeah, we get hung up on special needs, and that's no bad thing in a way. If you look at the numbers, and I don't quote me on this, etc., but Department for Education quoted something like 450,000 students in the education system right now qualify for special needs treatment. That includes disabilities. Not all those students are in a wheelchair being fed through a straw, having 24-hour care. Some of them are, and those sort of students are going to go to a special needs school, a school that is purpose-built for the sort of needs of the community. The vast majority of those special needs are people who are slightly on the autistic scale or have ADHD or something like that. They're going to go into the national classrooms of our big schools and have to be taught by the average teacher. A teacher that knows their stuff but may not be prepared for someone who likes to climb because climbing is exciting, that sort of stuff. So we don't have to design necessarily all for wheelchairs or all for deeply autistic people. We have to recognize there are some things we can do that will cater for lots of levels of autism or ADHD or other disabilities. I think the first thing is you need to think about color. Our eyes see the colors reflected off surfaces by the light that hits them. So if we buy, for instance, cheap LEDs, they won't come with good quality reds. So this lovely red lettering here is not going to come out. Now, in most cases, autistic children will respond to some sort of color tones. So what do? Do we ignore the red and take the red out because we've got one or two students who have got autism? And we can't do that because the other students in the class need to know what good red looks like. So we can give them things like filter glasses, which take out the unique spectrum that triggers them. So we'll build a classroom with really good spectrum of light, and then we'll filter out for the special needs, because each autistic child you've just met one. It's that great phrase. If you met one autistic child, you've met one autistic child, because the next one won't be the same.
And the needs are very different.
And their needs are very different, and you have to understand those needs. The next thing on the list, I think, flicker. Actually, this was mentioned to by someone who said, "Oh, you don't want fluorescent lighting because it flickers."
Well, all lighting flickers.
Well, all lighting flickers. Well, perhaps not daylight, but and perhaps not tungsten. But what they meant was the noise from the fluorescence. What they interpreted as flicker was distracting. So it got us on a whole conversation about, well, is it the noise or the light that's distracting? And it turns out it's both. So if you can take out old switch start fluorescent, which can have some noise in it, and replace it. Now, your only choice at the moment, we'll talk about this, your only choice is going to be LED. Absolutely. Because the legislation is going to change next year and fluorescent is going to go off the market.
The lamp ban is coming up in August next year. It's starting to come into effect. It's taking out the older technologies, CFL.
So you'll have an overlap where there will be lamps still in the wholesalers and you can purchase them. But you're going to face arguments about how you finance changing your lighting to LED. So you've got flicker. The noise is going to be got rid of because electronic gear. You still got flicker. If you buy cheap drivers or you insert dimmable drivers, you can introduce flicker. And that flicker is a problem. It's actually a problem to all students, to all human beings. Yeah. Good research suggests we can see, that we have this thing called the flicker fusion frequency. When you're watching TV, it's about 60 or 70 frames per second, and we don't see the individual frames. Our eyes blend everything to one, and we see a moving image. Yeah. Subconsciously, we can detect probably, some people say 200 hertz in the retina, some people would say 800 hertz. There's some evidence that the optic nerve can pass 800 hertz. There is some research out there that up to 2000 hertz can be noticed. So you need good quality gear that introduces flicker way beyond that. Interestingly, the only standard we've got, i.e. IEEE 1789, is 162 hertz, which is pretty low. We need to improve on that. Why is it a problem? Most lighting standards talk about a human being sat at a desk doing a task, looking straight forward or looking straight down or something like that. We know classrooms are not like that. When was the last time you sat in a meeting and just looked straight? I'm going to look straight here. No, what you do is you look around the space. And as you're moving, your eyes are also moving around the space. Yeah. So you have this thing called a saccade. Your eye moves from point A to point B because it wants to look at point B. And it takes kind of a snapshot at point B and fills in part of your brain image of what the room looks like. But going from A to B, the brain ignores all the imagery in between.
Oh, wow.
A and B, you forget what you see in the between. Technically, you do see it. Now you introduce flickering light, and the light creates a snapshot as your eyes move at something like 700 degrees of arc per second. Your eyes move.
So your eyes are acting like a scanner in between these 2 points, isn't it?
And when you have flickering light, that scanner takes a picture because it thinks, oh, I've got to take a picture. The light's changed. We respond to changes in light. Yeah. Our eyes are drawn to flicker. So we're going to process a huge amount of information. And in special needs children, that can distract them completely. It can take their attention away. Now, if you look at some autistic children, there's a test where you have a dot that changes color in the center of a card and there's movement around it. Mm-hmm. And some autistic children won't see the movement. They'll be so focused on the dots and wanting to see the change in color, they won't notice the movement around it. And others will only notice the movement around it and won't see the color change. Oh. And most of us who are not on that far on the autistic scale will see the movement and be able to process it. But flicker can cause headaches. It can cause migraines, which is different from a headache. It can cause alpha wave entrainment. So it can cause
what's alpha wave entrainment?
So inside your brain, you have a number of different waves, formats of the electrical energy passing through your brain. And alpha wave is one of those that synchronizes a lot of the systems in the body. varies between about 8 and 15 hertz. Okay, in people who've got epilepsy, the trigger frequency is particularly around that 15 to 20 hertz, because what happens is the light entrains the alpha waves. It changes the time signal inside your body, which can cause some upset. Okay, so it's very clear in lighting, we have to avoid that sort of up to 20 hertz, probably up to 70 hertz for flicker fusion. And then we need to probably go beyond that for comfort and for brain processing power. So attentiveness can increase, productivity can increase if we reduce flicker. What we tend to see is where we have flicker, attentiveness drops. Yeah, we don't get the same attentiveness or the same productivity because our eyes are just processing all this information that we don't really know.
The distractions that you're causing is taking away from your ability to process, to learn, to absorb the information. So yeah, we need to reduce those distractions. But you have other types of distractions as well, which I guess not just for special needs, it's for everyone really, but things like glare.
Glare would be one, in the same way flicker is points of light going on and off, so it attracts your eye. Glare is the same sort of thing. Your eye wants to look at the brightest point in the field of view. Why? Well, it used to be the raindrop on a leaf being moved by the predator. You know, it was important to see the light change on that leaf before the saber-toothed tiger jumped out and got you. And you know, we like to think we've moved on the last couple of 100 years, but a lot of our brain is still a millennia behind. So brightness in the field of view that is uncomfortable or attracts attention will cause us to look at it.
Yeah.
So in some cases in autism, that can be a real problem. Glare can be a massive, massive problem. So you want luminaires and indeed daylight. You know, let's not just blame it on the artificial lighting.
Absolutely.
You want good daylight control, keep the sun out, or at least attenuate the sun so it becomes daylight, softer. Good optics, lack of flicker, so good drivers, position in the right place.
Absolutely.
And if you think about another need, you know, when we talk about glare, you might be focused on what's happening on the table, you know, because schools are about writing on a table, aren't they? No, they're not. About
really.
80% of schools is about communication and boards and images and so on.
Taking information from person one to person two, and most of that information is not really from what you hear; it's from
what you see.
What you're seeing.
Yeah. So if I can't hear you, if I'm hard of hearing, I'm looking at your face. I want to see if you're smiling or if you're aggressive. I want to see if I can read your lips, because if I can't quite hear you, I need to see the form of your lips to know that you're forming the word that I recognize. So light onto the face is critically important. It doesn't happen from the desk. You get some bounce back from the desk maybe, but light on the walls bounces, becomes softer, lights the face. So flow of light is really important, and reducing that glare, because glare can be reflected in photographs, in glass, in window glass, in polished surfaces,
in the interactive whiteboards, tablets, laptops,
imagine you've
computers. There's a plethora of things in the modern classroom that can really sort of introduce glare as a problem.
I can give you an iPad to learn on, but the screen's glossy. I can give you an interactive whiteboard, but the students don't necessarily sit at regimented rows of desks. They come forward to sit around the teacher while something's explained on the board. Well, now the light that was nicely reflecting onto the floor might be nicely reflecting straight into the eyes of a student. There's glare.
So I guess with sort of students, depending on what age, I mean, primary students are learning everywhere within the space. I mean, every surface is a learning space.
Most classrooms at primary level are flexible spaces.
Absolutely.
And that raises problems for us if you think about things like standards. You know, why would you put 300 lux in a classroom, wall to wall to wall to wall, for a student? Because the furniture might go anywhere. Well, the truth is, what you need to think about is how you design your lighting so that I can give light onto the surfaces that are needed as and when needed. Now, government might not pay for that, but variable lighting might be the way around it.
That's one of the things worth mentioning just very quickly, is that the standards did change in 2021. So EN 1244 Part 1 2021 added the context modifiers.
Yes.
Which introduces different levels of lighting dependent on who is using the room at when. And there's always been an age-old confusion anyway with what
that hasn't
to use.
There's been not a confusion, there's been I don't want to do it. You know, because if I say young children at primary school, about 300 lux appears to be right. They're not doing heavy reading tasks, very fine print, you know, very small print. They're not doing that. They're doing much more broad stuff. The images tend to be clearer colors, the text. So 300 lux is about right. Now, that was originally a line in EN 12464. It's now been taken out and it's in the comments at the end. Lighting for younger pupils, 300 lux. So the headline figure is now 500 lux. Now you get those people who come in and say, 500 lux, that's energy inefficient, isn't it? So let's go to 400.
What's in between the two?
Yeah,
Let's
let's
see
go
if
in
we can
between the two.
balance for one and the other. I
Yeah,
think that's the age-old sort
Which
of
I hate, because
issue.
300 lux is kind of good enough for a young student. 500 lux is about right. And there's some really fascinating numbers on what's right for people. So let me just have a look at the numbers here. So if you compare 16 to 30 age group, so we're not talking young students here.
16 to 30-year-old.
Yeah, so university, A-level university, that sort of thing. If you give them enough light to perform at 100%, and then you compare them to the next age group up, so 30 to 45, and then 45 to 60-year-olds. So if you give 300 lux, the 30 to 45-year-olds will drop in performance by about 18%.
That's a huge decrease in
wait till you get
learning percentage.
Wait till you get to my age group.
It gets worse.
We drop by 45% in performance.
45%.
So you put me in a classroom at 300 lux, I am never going to compete against a 16-year-old.
Wow.
I simply, my brain can't take in the information because my eyes can't read it. Now, if you go to 400 lux, that's the step gap. I don't want to do 500, I'll go the halfway house. 15% drop for the second age group, okay? And for the older age group, still a 43% drop in performance. So by saying I don't want to do 500
for those needs of
not.
anyone that might be the older age group, and that includes teachers as well as students. Right? It's not just the students, it's the teachers being able to teach, being able to.
And lots of older students coming in the evening to do French and German classes or cookery or whatever. If you go up to the 500 lux, there's still a drop off, 13% for the 30 to 45s and 40%. So it's still a big drop off.
Yeah.
So it suggests the context modifier is a good thing, which goes up to 1,000 lux. So now if you go up to 1,000 lux in an adult classroom, the poor old 45 to 60-year-olds still drop by about 26% in performance. If you follow that line,
still a 20% improvement. Right?
Still a 20% improvement over the 300 lux. It's a massive improvement, isn't it?
Absolutely.
And if you want to do it so that the 60-year-old can perform at the same rate as a 16-year-old, 2,000 lux. And we're not going to.
We're starting to get into a territory which is how do we then cater for that? It's unaffordable.
The numbers of luminaires, the output of the luminaires, the energy used, the carbon use. It's just crazy. You've got to have a mid ground somewhere. 500 to 1,000. So 500 for older people. Maybe give them a task light or an additional 500 lux if they want to do fine level reading.
Okay.
Maybe if they're in a science class or something like that, 500 lux is more appropriate. Maybe, but again with task lighting, like you would do on, when you're filming something or when you're looking through a microscope, you put additional lighting.
Yeah.
Okay, so we should take that approach that we don't need to necessarily put 1,000 lux into classrooms. We might need to put task lighting, or we may need to put lighting controls in so that you have the ability to do 1,000 lux when it's needed.
Absolutely.
English reading.
Which are going to be specific times of the day. It's not going to be all day every day. It's going to be there when you need it. So again, it's back to that first argument we were saying. It's like what you need, where you need it, and who is using it.
Yeah, and the risk with the modifiers in the standard is, the standards are there.
It's guidance, really.
It's not great lighting designers who need it. If you talk to some of the great lighting designers, they don't look at the standards. They know what works. They don't even turn on a piece of lighting software to calculate. They know what works. So they will vary when they need to. It's to stop bad practice. That's why the standard's really there. The problem is when you put a standard in that says you can go up to 1,000 lux, that's introducing quite a lot of possibilities for bad practice. What you must do is justify why. And the sensible approach is to put lighting controls in that stop that task being overlit when it's not needed.
That's a really good point. So given everything that we've been discussing so far, it's leading up to a point, isn't it? Especially if we talk about refurbishment, it's an ongoing topic, whether that be an old building that you're then trying to refurb, or a much newer building that still is going from a T8 or T5 technology into LED. How should we approach this refurbishment? There's a traditional sort of feeling that one in, one out's an acceptable solution, but it kind of doesn't really cater to everything.
Yeah, you've got so much more of a challenge than that. It's challenging in new builds. You've got modern technology, modern architecture, and you're trying to create an energy efficient space. You've got currently 6 weeks to design that by the government standard. That's
6 weeks is not a lot of time, is it?
From dot on a drawing to finished drawing, all specified about 6 weeks, and the government wants to get that down to 3.
3 weeks.
Yeah. Wow. So let's not put new build as being less challenging.
No.
When you've got refurbishment, now you've got old building materials, old time style windows, poor thermal properties, old lighting, old cabling, old control systems. But you've still got to teach the same students to the same high standard, I would hope, or give at least the teacher and the student a chance. And there you've got to start thinking about, well, how's that done? And at the moment, our value judgment is cost. How do you specify a school? What's the cheapest bid? Yeah, I want to upgrade my lighting. How can you do it? What if I could take 3 fittings out? So go from a 9-fitting classroom to a 6-fitting classroom. That would cut the cost, wouldn't it? Cuts the installation cost, cuts the wiring cost. It makes
you introduce other
horrible.
issues and direct light, no light on walls, ceilings.
It's a bit of design
surround areas.
You design for the desk. And that doesn't make a great learning environment. Light onto the walls, light onto the ceiling, light onto the face, light onto the board.
You lose everything by trying to value engineer down to that point.
So let's say 9 fittings is right. I mean, there could be someone comes out with a 6-fitting proposal and it really works. And, we've been trying for 20 years, it hasn't happened yet. And optics really hasn't changed that much with LED. So let's go back for 9 fittings. So you've now got to take 9 fittings, maybe take out 9 fittings, replace them with something modern. Maybe you take out linear batten fittings and replace them with square luminaires. Maybe the ceiling also changes for acoustic properties. You've still got to get the control to those products. So you may have to rewire. Maybe your cabling is actually pretty good and you don't want to rewire, but you want some controls. So you might use Bluetooth or Wi-Fi. You might use control signals put down the power cables. That's possible as well.
There's also Wi-Fi the option these days as well to hybrid between the two.
Why not?
It can be a bit of a mix as to what's the best solution for the building. I think.
So you can materials
interfere as well.
Yeah, you could. Yeah, well, I mean that's worth talking about. You may have an old building, sort of Victorian building with brick built with high iron content in the bricks.
Oh, wow.
Wi-Fi and Bluetooth are not going to get through those bricks, and there'll be solid brick walls.
So you need to look for solutions that.
You need to get that signal through the door to the classroom because that's the weakest point, or even through the windows. Windows can introduce other problems. If you've got high-end detector systems, radar-based or whatever, ultrasonic, they're going to see through windows. They're going to see through plasterboard walls or something like that. They see through doors.
So you get the false triggering from external factors into your building.
And then you've got to have a client who knows what they want. I want lighting for my classroom. How am I going to do it? Well, I met one guy who said, well, I'm getting fittings for £20 a time. And I said, well, you can get them for £12 a time if you really look. He said, well, where from? The fittings he was buying flat panels. They had MDA diffusers in. So 6 months later, they're going yellow. And what you can see is these 2 bright bands down the side and a big yellow panel in the middle. And he said, what's wrong? I spent £20 on them. They should last.
Well, I mean, they should last for a point in time. And I guess the time of the installation of a building is much longer than most lighting solutions anyway. So,
well, if you think
it kind of promotes a different sort of viewpoint as to how sustainable can your refurbishment be.
Well, you think about the price of a luminaire, £20, and it was lasting 6 months before it looked horrible and the light was £60. It was a reputable manufacturer, and that light fitting is going to last 17 plus years. And I know that because there are some of those luminaires still in place from the early days of luminaires. So there are manufacturers out there who are making good stuff, but it's not the cheapest. Now, a school's going to last, 100 years? Probably. Brick building, maybe up to 120 years. So you really want lighting in there that's going to last a good proportion of that. 17 years suddenly doesn't sound very much, does it? But LED may have moved on, and we may be on laser LED or something else later in the lifetime. You may want to replace luminaires. But I can't see a way in the future where you can literally take a luminaire out and throw it in the bin. That's not sustainable. Look at the plastic problems we have in the oceans. You can't take out MDA panels and just throw them in the bin. They've got to be upcycled, reused, recycled, whatever it is. And I think the same goes for the LED, goes for the gear, goes for the metal housing.
So the maintainability of the product, its recyclability for areas where you can't just simply swap in and swap out componentry.
But you go back to that poor guy who's buying fittings now at £20 and you say,
you're not going to worry about that sort of
flicker,
ability,
color, glare, dimmability, lifetime, material content, whether it can be recycled or reused or refurbished, all that sort of stuff. You're not going to get that for £20.
No.
But you're going to take away that value judgment and say, don't think just about cost. Think about embedded carbon through life. Embedded carbon through the life of the building. Think about this. You have a school that lasts 120 years and it gets used 6 hours a day. I mean, no school does, but let's say it gets used 6 hours a day. And it's got embedded carbon in it, 490 kilograms per meter squared, typically for a new school. And now you say, well, what if I use that school now for 12 hours a day, double the amount of time? So I open it in the evening for sports or for French lessons. The embedded carbon per hour of that school now comes down. It halves, twice the number of hours per day. Now, if you think about the lighting terms, it's not quite so fair, because in lighting terms, you may not need the light during the first 6 hours of the day. When you extend the daytime into nighttime, you need the lighting. So the carbon investment goes up by having artificial lighting. But overall, the carbon embedded in the building per hour comes down.
And that's what we want to be looking at.
And that, when you talk about the life of the planet, people who are going to use our buildings in 120 years' time are really going to care about that. So we should be planning buildings now that will last, and services that will last. And that takes us away from cost to real value.
But how do you then sort of back that up? Is there certification or regulation that's coming in that kind of people can look to for that sort of guidance? I know from Thorn perspective, we provide environmental product declaration, which is essentially brings the detail together that you can assess a lot of this criteria.
You're surprised how many people don't. I have, as a lighting designer, I struggle to get photometry, or data sheets from some brands. So to get an EPD, environmental product declaration, is quite difficult. Some of the major brands doing, I know Thorn and some other people have done it for more like 15 years now, and I was involved in some of the setup. But there has to be more than that, because you're going to take that product, and let's assume you recycle it. So the EPD just says how much of the material you can reuse, but you've got to have someone at a desk somewhere taking the components apart and saying, well, this component I can't reuse, so it has to be recycled rather than throw it in the bin. Or this component actually is in perfectly good nick. It's got another 10 years of life, so I can reuse it. I can put it back into the supply chain. Now, how many manufacturers are really set up to take that stuff back? Or how many manufacturers actually would take the luminaire off me right now and say, I can repair that for you?
I mean, it's a very difficult question, because there's a lot of logistical issues in the background with it, but it's certainly something that the changes are coming very quickly now, and trying to get manufacturers to move around to that speed is often very difficult. You've got to try and set up processes in the background to be able to deal with it. But certainly it is, from Thorn and Zumtobel Group perspective, something that is being considered and looked at.
And you need to seriously consider.
You've got to really consider what it is you're trying to replace.
Well, and in design now, I mean, your products now have to be saying, how do I? Well, let's call it preventative maintenance. I mean, why is this not going to work? Why is this not going to work? An electrician gets paid to install a luminaire, and gets paid perhaps to go back and maintain it, like fitting veils, goes back. So actually, it's in his or her interest to have luminaires that don't last very long, because they want to stay in business, so they want to maintain stuff. Now you take that away and you say, I'm going to have luminaires that can be fixed, but I'm going to take the luminaires back to the factory, and then I'm going to ask you to put them back in again. And the cost is not right. The value judgment for an electrician is not right. But now if you paid electricians to do preventative maintenance, so instead of them going in and saying a luminaire's failed and take it out, they come in and say, I noticed that with these luminaires, we're probably coming to the end of the life for the gear or whatever. So what I'm going to suggest is we take this group out, and I'll replace them immediately for you. And this stuff will go off back to the manufacturer and be refurbished, and we'll have it in stock somewhere, and I can retrofit it when something goes wrong. So an electrician doesn't become someone who just handles cabling. They become an expert in preventative maintenance. And when you've got that sort of value chain in our customers, our installers, you've got clients who can't throw stuff away because it will become illegal, and you've got manufacturers who are designing in circularity to their products. Then you could actually have a nice little new way of supplying and using and refurbishing lighting that means it might last the next 120 years, like hopefully the brickwork in the building does.
Absolutely. I can confirm that the circular design rules implemented at the Zumtobel Group are starting to take effect, but it does take time to get that through to a whole product range. Essentially, overnight the light was turned on with TM66 and the circularity argument, and then manufacturers are left going, oh,
how do we do it?
And customers don't want to go all the way back to the beginning for every single product, and it does take a bit of time.
And we've got some time, but our other goal is net zero.
Absolutely.
So we want to get buildings down so that they use less carbon than they generate. That sounds a bit wrong, doesn't it? But essentially, they're not a net contributor of carbon. So you're going to have to do things like that, because lighting will always use some energy.
It will.
Now you could do solar panels, batteries, DC powered LEDs. I mean, that's another place as well. So perhaps they're not contributors of carbon, but you've got to refurbish them as well. Otherwise, all that embedded carbon in a product And I've seen some of the designs coming along, the fact that you can take LEDs out, gear out, whatever, snap together stuff that will last. I think it's fantastic. Our next biggest goal is to get our customers to value that.
I think so. I think that's the biggest takeaway for me, is to try and understand that there is that value in it. There is a reason for it, and it doesn't just happen.
And to do all that, we go back to our poor guy who's buying fittings at £20. So now he's got to think about circular products and how he finances and pays for that circularity.
Absolutely.
When he hasn't got a budget, he can't afford it because there's no funding out there, or he can't access the funding. And he's still pushed back to cost, when in fact what we want to do is all these lighting qualities, all these energy qualities, all this circularity, and still teach.
I guess just the final point before we sort of wrap up is that there are certain funding mechanisms, whether you're in England, Wales. I think the government has announced something.
Yeah.
Further afield in Europe, there are different ways you can go and get funding. So we do have some of that knowledge in the business to help with that. Certainly worth asking the question. I don't know if there's anything to touch on with certainly from the UK.
It's difficult as to how you access the funding, and depending on which country you're in of the United Kingdom, there will be different ways of doing it. But the theory is that you can access school refurbishment funds. There's a couple of different ones, and I can't remember the names. But you fill in a form on a website, and you send it in the DFE, and you get a decision on whether you get some money. I hear that it's not as easy as that. If you remember, enhanced capital
asking for money from the government is not always the easiest thing.
It was always a good thing. I think when you look at refurbishment, there's always that. I'm going to go from probably old fluorescent to new LED. There's an energy payback.
The energy itself, the reduction in the energy is going to pay for that service.
Yeah, and right now, with energy prices so high, I mean, I know they're coming down a bit, but let's assume they carry on rising. Right now is a good time. Because your calculations give you a relatively short payback. We shouldn't be talking 10, 15 years. We should be talking 3 to 5 years, or maybe even less. Typically a downlight is 6 months going from compact fluorescent to LED. So why not do it?
Absolutely. Well, look, thank you so much for that discussion. That was really, really interesting. Really great to hear your thoughts on the conundrum, and I hope people have found that a useful and informative session to listen to.